Hello everyone, it's December 5th. We still have this unresolved. I think the idea works. Now you pick just two parallel lines and then find the total number of parallelograms in them, and then minus those values. I think it sounds good. It may be costly, but I feel like it might work. So we'll definitely revisit it, but not today. I don't feel like doing it again. Count partitions with max min difference. At most k, you're given integer nums, and at k, your task is to partition nums into one or more non-empty contiguous segments, such that in each segment the difference between its maximum and minimum is at most k. Total number of ways to partition. So partition into one or more empty segments. So yeah, you can do every single one. I think it will work, right? And then you can group them together, and that will also work. So we have 9, 4, 1, 3, 7. This is what we're starting with. And we want to know how many different ways we can partition such that it can have all the segments, the difference is the most k. Alright, it smells like DP to me. So what if I already know how many to partition? If it's one, right, that's just a one way. If it's two, if I already know this, right? So 2 by itself is a one way. And then I need to ask, if I combine this, does it work? Right? If it works, then that can be 1. That's the maximum of this. Right? And then I keep include and I ask this, keep include, ask this. So essentially, there's just more ways, right? So basically we have this by itself. So yeah, so we have A0, A1, A2, all the way to AI, right? AI minus 1 and AI. So if I want to do AI, let's say DPI, right? DPI shall equal to by itself. So we have, it works, right? So like whatever this, so it's dp I minus 1, whatever, however many ways they have, and then we'll have just that, and then whatever this, plus we'll do this, right? So dp I minus 2 times whether this is a good, a 0 or 1, right? So is it good or is it bad? And then I will plus, dp I minus 3 and also a 0 or 1, right? So we can do this all the way to, plus dp 0, right? dp 0, then we need to know if this is good or bad. Now the thing is, once we have one of them as bad, you don't have to keep going. You don't have to keep going. You just need to keep until you have the first one that's bad. Okay. So the first one that's bad, basically what you're going to have is this plus this plus this until you hit a bad one, right? So you just have a subarray which the min max difference is smaller or equal to k. Okay, then the question, so we can have these dp values. We can even put them into a prefix sum, which we can solve this problem for us. You can also have the entire thing, right? Yeah, you can have the entire thing. dp, well, not just dp0, because we are doing this, right? And dp0 within this. And then that's, right? And then also plus 1, like if the entire thing is good. So that's also one way, right? So the question is, starting from here, starting from this counting this way, what is the maximum reach you can have such that it does not give you a it give you the maximum? K is equal to 4, right? How do you handle that? So I have this. If I move to, so we just need a range such that the difference of the min max. So we need to know the min max of a range. But that requires to go one by one, which I don't think this is what we want, right? What we want is, given an index, what is the maximum range such that its min max is smaller or equal to k, right? Smaller or equal to k. Now I know from this, right? From this I know. Let's say the min max is this, right? Let's say within this I also know I know the min, I know the max, okay? Now, if I want to include this, if this is within min max, you're just gonna extend, no problem. If this is bigger than the max, right, then it doesn't work. You have to redraw this, right? You have to redraw this, and redraw this. Redraw, that's not what we want. Yeah, so we know the min max. Ending at this, I know the range, okay? It's not min max, I just know the range. The maximum range. We have some max, we have some min, and everybody else is in between. So we can we have the maximum range up until a point. That just means if we keep going, it's gonna be too big or too small, right? So we stop there. So we have the range. And then the new one, if it's within the range, I just extend. Now the new one is bigger than the max, but it still works, so I'll also include. Or if it's smaller, then I'll also include, right? So trouble happens when it's too big, right? Which means I need to know where the small is, right? So we have the smallest, and then if I know where the small is, then I just move one spot to the right. But then what is the next smallest? I need a prefix. I need to know what is the smallest in the range. There's no way that this will require that complex. I don't think so. So there must be something that you're not realizing. I mean, we can use a counter, like a sliding window, right? So we have a map, right? So it's sorted. So we have a sliding window. Okay. So basically we know this is a window. Actually, can we get a min and max? How do we get a min and max? Can we get a min and max? Like map get smallest and largest key. How do we do that? Begin and end. I see. Begin and end. Okay, begin or begin. Right, begin and or begin. So there is a way to get. Okay, so yeah. And then if we're gonna include a new one, so I checked smallest, I checked the biggest. I can even just keep track those two values. So I check it's within, put it in, and then we keep moving, and I have the index as well, right? So and then here, if it's bigger than max, and then this, so then we need to move here one by one until the min gets bigger. Because okay, like if this is big, right, we just move here. What if this is super small? What if this is super small? Then the same thing. Oh, you have to get a max. So basically, whatever this is, the min minus this and the max minus this need to be within this. Okay, so I think that shall work. We have a sliding window to keep a range, right? That is good, and then we just need a DP, a prefix sum, such that we can do this. We can do this, right? So basically, starting from here, we're gonna add, right? So DP this, because it can include it can we like these two can be together. We want to know who can be with this new one, right? So these can be together, which means I can do this by itself, and I need to do this, right? And then we'll be I can do this, then we'll be adding this until this is the last one. So we do the one to the left, right? The one to the left, and yeah, okay. So I guess if DP, we can call it P sum, right? P sum. But P sum 0 is 1. P sum 1 is also 1. That's just by definition, is because you take this and then you do this plus multiply by u, right? Multiply by u, and then require some three, 5, 7, 8. Right, so dpi equal to the number of partitions ending at nums I, right? to compute dpi, we can take nums_i by itself, right? Then we add dpi minus 1 number of partitions. If dpi can be grouped with dpi minus 1, then we add another dpi minus 2, right? So on and so forth until we reach a dpj, right? We reach a dpj such that dpj towards I do not satisfy the requirement. Then the total number of partitions ending at nums_i would be dpi minus 1 plus dpi minus 2, right, plus plus dp. Do we reach j? So if we reach dpj, so this is bad, right? So I do so I cannot hit j, so I hit j plus 1 is good, right? So j plus 1, so it's dpj, right? So to dpj, this can be efficiently computed using a prefix sum. Now the next question is to quickly find what is the max range, max subarray ending at nums_i such that it satisfies the requirement that the mean max difference is no bigger than k. We can use a sliding window to find such range, right? To find such range. All we need to do is to keep track of the min and max value, right? We can do so using an ordered map. For a new nums_i, right, if it falls between the previous min and max, we simply extend the window. Otherwise, we need to shrink the window from the left until the new range satisfies the requirement. We rely on the ordered map to determine when the min or max value need to be updated. Okay, so this is kind of the idea. I believe I'm gonna call it Owen login. Alright, so let's do this. So we have actually I don't like to call it dp. Let's call psum. Oh wait, hold a second, we can call it dp, it's okay. We'll just do psum here. So psum is going to be a vector int. Psum we are going to do, just put a 0. Oh, put a 1 in there, right? Put a 1. And then we say, you know, j is the one it cannot reach, so j equal to 0. That is totally fine. And then we say for int I equal to y smaller than nums dot size. Actually, I should be smaller, equal to and then I plus plus, right? So what we want to do is, oh, we also need a map. So we need a map. So std map int. So this is what is this? This is going to be window min max count, value count, right? Value count. Okay, so int current value is nums I minus 1, right? So what we want to do is we'll shrink the j. The j value is interesting. So I is at 1. That's more or less to satisfy the p sum, right? So j is actually pointing to p sum, the start. I is already pointing there. So I need to minus 1 to accommodate. And what about the j? So I basically said, well, this and this, one of them is bad. Then I'll take j. Right, I'll take j. So j shall just be itself. No, j shall be minus 1, right? I think j shall minus 1 as well. Because j points to the 1 that's bad. So j plus 1 is pointing to the 1 that is good, right? J plus 1 pointing to the good one. J pointing to the bad one. J plus 1 pointing to the good one. So we're doing j plus 1 to I. This is the good range. Right, so we basically just from j plus 1 and then moving forward. Yeah. So we say while val count dot empty. If it's not empty, right? And one of them, right? And one of them. We say val count dot begin dot first minus nums minus current. If this is larger than k, and we'll do ABS, right? If this is larger than k, or ABS val count dot reverse begin dot first minus minus current is larger than k. Well, I believe this is this, right? Or this is larger than k. If this is satisfied, then what we need to do is we call val count int to remove equal to nums j. So it's j plus 1. That's the one we need to remove, but it also needs to minus 1, so it's nums j. So val count to remove minus. It's fine. Let's just do this, right? So this one, this, and we should say if val count nums j. Well, actually, we did that. At nums j is equal to 0, then val count dot erase nums j. Okay. And once it's done, j will plus plus. Right, j will plus plus. So we do that until it gets out, then we have a j value, right? We have a j value, and what we need to do now is we'll definitely put current into the count, right? But basically from j plus 1, right, from j plus 1 all the way to I, this is the maximum range. So what we need to do is the p sum, right? So the p sum is going to be from I minus 1, right? Because if I'm at I, right, I'm at I, it has to be from I minus 1 plus all the way to j. So what if j and I, they meet each other? Totally possible. They can meet each other, right? Yeah, what if they meet each other? J plus 1, right? And then I, they meet, so they just, so like this is gigantic, right? And everybody else, that's just no good. So in that case, the result shall just be if j plus 1 is equal to, right, if j plus 1 is equal to should it be 0 at the start? Because otherwise we'll do this minus this. Right, well, it's a little bit. So basically what we have here is the range is j plus 1 to I, right? This is a good range. So if I want to find the p sum, it's going to be p sum I minus 1, right? Because I don't add this, it's p sum I minus 1 plus 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 minus p sum j, right? This is what we want. So if I is equal to j plus 1, what's going to happen is I minus 1 is equal to j. Yes, I minus 1 is equal to j. So this will become 0, right? This becomes 0. But that is not good, because if it's 0, then we are not adding anything. But we should, right? We should, which is the edge case, right? Which is the edge case. So if j pointing here, if j plus 1 is 1 to I, and then we're trying to say, okay, we can hold the entire thing, then it's going to be you know, this, right, minus this. So we want to know the total number of ways. Total number of ways of doing this, of doing this, of doing this, and then it's just the total number of ways of doing this, right? the number of way of doing this. So yeah, that's the thing. Like if I have the entire thing occupied, right? Because if we do this, we use this plus this, and then we should do this, right? I minus 1. Let's say this is a 0. Right, so I minus 1 becomes 0. And then j is also 0. So we come back to this scenario. So it's just when this becomes 0, we shall just assign the value 1. Right, if this is 0, then we just assign value as 1. But in reality, it's because I'm holding here minus this, right? And minus this. Because I'm doing this plus this plus this plus this plus this, right? And plus all of them, and then we are basically plussing this thing, right? We're plussing this thing. So if the entire thing is within reach, right? If the entire thing within, because I say this, so I'll do dp this, right? Plus I include this, dp this. I include this and dp this, right? dp this. And dp this has to be dp this is just 1, right? Because you just only have 1. dp this is just 1. But then if you do a prefix sum, right? dp this, so a prefix sum of this plus this. So oh my god, it's, I think the indices is really okay. Okay, the indices are really messing me up. Okay, the indices are messing me up. I think I'm gonna make it simpler by not putting anything in there, and then we'll use just if. We'll just use if clause. It's okay. So this is the start. Okay, this is the start. And then current is this. All right, and then this is all fine, right? And then j will do this, will do this, and j plus. This is all fine. Okay, this is all fine. So now what we have is j to I. This is the range, right? This is the range, and then we want to find out. So nums j to I, right, is the max subarray, right? Max allowable subarray. We need to find the sum of num of dp I minus 1, right, plus dp I minus 2 plus plus dp basically j minus 1, right? J minus 1. That's what we need. Until reach, yeah, this is not what I want. If dpi until we reach dpj such that dpj is the max subarray that satisfy the requirement, then we'll add to dpj minus 1. Yes, this is correct. Okay, this is correct. So this can be done by a prefix sum, right? By a prefix sum, unless j is equal to 0, right? If j is not equal to 0, then we can always get it done. So depends on what the j is. So if j is equal to 0, right? If j is equal to 0, that means we don't have a j minus 1, right? We don't have a j minus 1. What it means is, because j minus dp j minus 1 is like saying, because you're including j, so you're including this, and then what is the maximum for this, right? And then for this is just going to be 1. So if j is equal to 0, right? If j is equal to 0, then so it'll be p sum I minus 1, right, plus 1. This is gonna be p sum is everybody adds together, right? Everybody adds together, so we'll also need the mod. Right, we need to mod it, yeah. So p sum, so that's the just previous sum, because p sum is everybody adds together, right? So this plus 1 is going to be, because it's just going to be this times 1, this times 1, this plus, and then we have one more, because yeah, we just have one more, and it's going to be p sum dot, right, p sum dot push back, a new thing, right? It's going to be p sum I minus 1 plus this, and in order to make this correct, let's just do this. So this plus this plus this mod. Okay. Else, then p sum dot pushback is going to be p sum I minus 1 plus something, right? And then mod. What is this something? Well, this something is going to be p sum I minus 1 minus p sum j minus 1, right? Because j minus 1, so j is not equal to 0, so I do have j minus 1, and this, I think we should plus mod just to be safe, and then do this, right? So we have these two, this established what the new p sum is, and then we'll just keep moving forward, and we have to here say val count current plus, right? Yeah, I think we don't need current, just numzi. We know numzi, right? So after we're done with all of this, and then we'll return p sum dot back, something like this. I knew it. It's we have some issue. It must be pointer stuff. Pointer stuff is bad. Well, at the beginning, right, j is equal to 0, I is also equal to 0, so we don't even have I minus 1. Ah, that's right. We don't even have I minus 1. So what's pi minus 1 then? It's just 0, right? It's just 0. And so we can actually say a pre. Okay, how about this? We do a pre. We say int pre-sum, pre equal to I is equal to 0. If it is, it's gonna be 0. Otherwise, it's gonna be p sum I minus 1. Okay, and then here we're just gonna do pre plus 1, and then this is going to be a pre plus this is gonna be a pre minus this. Does this one work? No, it does not. It bloody does not. What the hell? That's alright. Let's debug this. What do we have? We have nums and k. Okay, we have nums, which is this. K is 4. Okay, what's this function? This function count partitions nums and k. Alright, let's debug this baby. We are at 6. And I want to go through every single one of them. Alright, let's do this. Okay. Nums, psum, I need psum. I need to count. Alright, it's empty. So we get out, value count, put in, 9 is 1, okay. And I is equal to 0, yes. So pre is 0, j is equal to this. So it'll be 0, 0 is gonna be 1, p sum push into 1. That's it. Alright, next one. Next one is, if I remember, it's 4. Okay, 4. So yes. And then j minus minus. Okay. So we remove j plus plus, so j become 1 as well. So I and j is equal, right? J become 1. And we push this in 4. That's not. So p sum I minus 1 is 1. Right? Pre is 1. So j is equal to 0, j is not equal to 0. So what I do is pre minus pre sum j minus 1. Oh, this is, I see the problem. Is this like you're by itself? So it's not j equal to 0, right? It's not j equal to 0. It's when j and I are the same. Also when j is 0 as well. So j is equal to 0, or j and I is equal to, or they are the same. Hold on. If j is equal to 0, we'll do this, right? And so j equal to 0 depends on I, right? If I is not equal to 0, then we have this. But if j and I are the same, if j and I are the same, then it's, yeah, then pre minus this is gonna be 0. Then it's just gonna be pre, right? It's just gonna be pre. Then it becomes 0. And you have 0. That's not right. Right? That's not right. Hold on. So this doesn't, yeah, this feels wrong. So basically we say pre-current, okay? So we say if j is equal to 0, right? Or we do current, okay? So if j equal to 0, then we say current shall be pre plus 1. Right? We can even do mod. Actually, this shall be a long, just in case. Long, and this is long as well. So this mod, right? If j is equal to 0 at the front, then it's just going to be the pre. Right, we have a pre. Because this is the entire thing. Why do you plus 1? Because j is 0. J is 0 means this entire thing, right? This entire thing is, because if j is 0, which means from here I can extend all the way to here, right? I can extend all the way to here. So I'm going to go this plus this plus this plus this plus this, which is the pre, and then into plus 1 because it can be by itself, right? Yeah, that makes sense. So else if j and I are the same, right? J and I are the same. So we say else if j is equal to I. So they're just focusing on the current value. So in that case, current is just equal to 1 because this is one partition. You don't have another one. Otherwise, then you have this current equal to this mod, right? You have the pre minus have the pre minus p sum j minus 1. That's the total sum in here. So everyone gets 1, and then because it's a minus, so you try to also do a plus mod, then you mod, okay? Okay, and then we say psum dot pushback pre, right, plus current mod. Okay, so that's slightly different. Hopefully it's correct because it's already been 50 minutes. I'll say almost. I still need to debug this. Okay, so first skip. Then pre is equal to 0, j is 0, current is 1, and then push back 1, done, next one, and on 4, so I have 4, 1, pre is size equal to 1, so pre is become a 1. So j is also 1, so those two are the same, so that's a 1. And then so we have 2, right? Next, so now we have a value as 1, and then the small and the large, so we jump out. Okay, so 1 push in, and then so basically if we take this by itself, we're gonna do this, or we take these two, we should do this. So because this plus this, so yeah, so j still at 1. Yeah, j still at a 1, so pre is going to be 2. Yes, j is at 1, I is at 2, so we jump here. Okay, so pre minus this, j minus 1, so just 1, right? Just 1. So basically we say this by itself, we can do this, and hold on. This by itself, which is the maximum of doing this, which is a 1. Or this go together, so the maximum of this, which should also be 1. Right, which should also be 1. So it should be this plus this. No, j minus 1 we need to include. Right, j minus 1 we need, because we have this to this, so this is the whole thing. So j minus 1 we need to add, so it's actually j minus 2. Right, it's actually j minus 2. Yeah, so this is j minus 2. It should be j minus 2. So, oh boy. Alright, coming. So j minus 2. Alright, let's finish this. So basically j equal to 0. We also need another if the j equal to 1. Else if j is equal to 1. Okay, if j is equal to 1, that means we need to add to, so basically current shall equal to just pre. That's it. And if they're the same, then we do this. Otherwise we do this. Because this is when we can do j minus 2. Right? We need to do j minus 2. Okay, let's terminate this, save this, and then okay, and also what are we looking for? The maximum, so it's actually not psum.back. No, it's going to be long current. I think the return value is current, because that's the maximum number, right? Maximum number ending at this one, because you have to do this partitioning. Okay, let's try this now. Okay, the first one is right, the second one is wrong. Expected 2. I got 1. Okay, let's debug this. 3, 3, 3, 4. And this is 0. Okay, so first value, jump out. So I have 3, have 1, yes. I is equal to 0, so pre is going to be 0, j is 0, it's going to be pre plus 1. Okay, so current is 1, so we push 1. Okay, so basically 3 by itself, right? Now we have 3, so if we have 3, we have 3 by itself, we also have 3, 3. So that should have 2, right? Current should be 2. Now we try to see. So this doesn't go, yes. So value basically 3 has 2, and the pre is not, so pre is going to be 1, right? Pre is going to be 1, that's this part. And the j is equal to 0, okay. So current shall be 2, which is good, right? So this push back. Current is 2, so ending at here we have 2. I have basically 1. Oh, yes, we have like 1 way, and then 2. So the total is going to be 3, right? Prefix sum. Next is 4. 4 need to be by itself because this is gone. Yes. Next, yes. So this is done. J is equal to 2, jump out. So val will put 4 in. So now j and I is the same. So current equal to 1. Oh, j and I is the same. J and I is the same. That's where things falls flat. That's not 1. That shall be pre plus 1. That shall be pre plus 1. Or I is equal to j. We do pre plus 1. Yeah, because you have to have pre, the total number, right? The total number is the number of ways. Hold. You are by yourself, right? You can only do by yourself. And then that should, hold on, that's not right. Redo. This need to be pre. Need to be pre because you're just by yourself, right? You're just by yourself. You're just by yourself. You're isolated, and then you want to know how many. Then it's just a pre, right? J equal to 1 means you have no, that's not pre. Okay, this is not pre. This shall be pre. It's dpi minus 1. This shall be dpi minus 1. Right, this shall be dpi minus 1. So it should be pre minus p sum, because you're by yourself, so this is the only thing, right? This is the only thing you can handle. And we don't need to know the number of ways that ending at here, right? So this whole thing, number of ways. So that's I minus 1. So I minus 2. Are you sure when you hit here, it's going to be, I is going to be larger than, well, I hope. But I is equal to 2, right? So it's the same thing. It's the same thing. So we're gonna go pre then. Okay, long pre. I is equal to 1. Yeah. It's not true though. Wait, hold on. What we want to do is this minus p sum I minus 2, right? So what if there's 1? 1 will not hit, so this is only going to be 2. Otherwise, p sum I minus 2. That doesn't make any sense. It doesn't make any sense. It's just 1 and 2 are the same, right? We need to get the previous one. Right, we need to get the previous one. And this j has to be equal to 2. And I is equal to 2, 0, 1, 2. So I need to get the previous one, which is p sum I minus 1 minus p sum I minus 2. Now in this case, I think it works. You don't have to do this. It will work. It will work. Okay, so basically we just need to change this line when they're the same, right? Change this line. Try it, hopefully it will go, but if it doesn't, oh, we have some, oh, my bad, yeah. Oh. All right, I think this one shall pass, but 1 hour and 7 minutes. And I'm pretty sure there are better solutions than this. I don't know what, but this one is very, I feel like this one's hard. I have no Ghana today to even read through the actual solution. I'm just gonna end it here.